Looking back in time, ever farther. In the 1920s, Edwin Hubble observed the expansion of the universe by observing the motions of far-off galaxies. The Hubble Space Telescope has pushed this boundary of our understanding further back, observing even more remote galaxies and seeing further back in time. But the Webb telescope can push still further, to the earliest stages of a galaxy's life. Like a kid growing up, the early days of a galaxy is where the most development occurs. Knots of stars and gas are just beginning to transform into the full-fledged figure of a mature galaxy. With Hubble, we can see the universe's awkward teen years. As galaxies grew up, the Hubble Space Telescope is currently pushing the limits of detection as far back in time as it can. But the Webb telescope is designed specifically to find this special time in the early history of the universe. Equipped with the latest technology, Webb will allow us to see the objects that brought light to the cosmos and unravel the mysteries of reionization. Only then will we have a better idea of how the universe grew into what we see around us today.
NGC 346, a star cluster that lies within a nebula, is located 210,000 light-years away. It resides within the Small Magellanic Cloud, a dwarf galaxy close to our Milky Way. New findings from NASA's James Webb Space Telescope reveal the presence of a much more intricate network of gas and dust structures than previously discovered in the area. Within this plume of gas is cold molecular hydrogen, which provides a perfect environment for young stars to form, some of which can be seen here. These young stars generate energy that heats the gas, energizing and splitting the molecular hydrogen. This effectively carves rough ridges into the gas. This area appears to show the head of a dragon spitting out balls of hot gas. Its eye and the balls of gas are areas of active star formation, which will continue to change the environment around it. These wisps are more evidence of that environmental change. Winds from nearby stars are blowing away material that surrounds still-forming stars, leaving these small structures behind. Here we see curly ribbons of glowing gas that outline the cold molecular gas of the region. These many pillars of creation show how pervasive the stellar erosion is in the region. Eventually, over millions of years, the mixture of energized and dense hydrogen will give way to thousands of stars and far more of these filamentary structures. NASA's James Webb Space Telescope presents a new view of Able 2744, also known as Pandora's Cluster, displaying various depths of space in a single image, ranging from a foreground star in our own galaxy to the megacluster forming as multiple massive galaxy clusters merge 4 billion light-years away, to the even more distant galaxies behind the cluster, whose light is magnified and distorted by the megacluster's warping of space-time. Without the cluster's magnification boost, even the Webb telescope could not see these faint, extremely distant galaxies. Some features that Webb shows distinctly, like this dusty red galaxy, were not detected at all when the Hubble Space Telescope studied the region. Astronomers are using this image to choose certain galaxies for follow-up to get precise distance measurements and details about intriguing features. This small red dot is a distant source of infrared light that has so far defied characterization. It must be extremely compact, because even with the visual stretching caused by the cluster's warped spacetime, it still appears as a tiny dot. One theory is that it is a glowing disk of gas surrounding a supermassive black hole in the early universe. Webb's follow-up observations will further reveal the wonders of Pandora's cluster and uncover a new understanding of the universe.